going to start by differentiating my substitution. So I'll get dx by du, cos differentiates to be minus sine, so I'll get minus 2 sine u. Making dx the subject, by timesing both sides by du. And so now I know I can replace this dx with the minus sine u du. Next, let's talk about the limits. So when x is root 2, that means that root 2 is equal to 2 cos u. Divide both sides by 2. And do cos inverse, and I find that u is going to be pi over 4. So when x is root 2, u is pi over 4. Now for the lower limit, so when x is 1, I get 1 is equal to 2 cos u. Divide both sides by 2. And do cos inverse. And I find that u is pi over 3. So when x is 1, u is pi over 3. Right, let's plug all of those values into this integral and have a look at this fraction as well. So my upper limit was pi over 4, my lower limit was pi over 3. And we've got 1 over, so this x squared is going to be 2 cos u squared, which will become 4 cos squared u. Then we've got the square root of 4 minus x squared, so 4 minus 4 cos squared. And not forgetting the dx that's going to get replaced with the minus 2 sine u du. Right, let's try and tidy this up a little bit. Let's focus on this square root here first. The 4 minus 4 cos squared, well, that's the same thing as 4 1 minus cos squared. Just factorising the 4 outside. Which I could then, well, this is just sine squared, right? The 1 minus cos squared there, I can turn that into a sine squared. Which is useful because the square root of 4 sine squared will just be 2 sine u. Which is then even better because that's going to cancel with this 2 sine u. And at this point, let me rewrite this integral again, because I'm going to take this minus 1 here and use that to flip these limits around, just so I have the bigger limit on the top and the smaller limit on the bottom. Now, this 1 over 4 cos squared, I can think of that as being 1/4 times 1 over cos squared. Clearly that's the same as that. And this 1 over cos squared here, well, that's just sec squared. And we know what sec squared integrates to give. It integrates to give tan. So all of this is going to integrate to be 1/4 tan u. Substituting the limits in then, we get 1/4 of tan pi over 3 minus 1/4 of tan pi over 4, which gives me root 3 over 4 minus 1 over 4, which I can combine to be root 3 minus 1 all over 4. Question 28. We are finding the area R with some parametric integration. So, we're going to integrate y times dx by dt with respect to dt. The y, we know what that is. The dx by dt, we need to find that. So we need to take our x function here, and I'm going to differentiate that with respect to t. Differentiate the logarithm, and I get 1 over. And the derivative of the t plus 2 is just 1. So that is just my final answer for dx by dt. So the y gets replaced with the 1 over t plus 1. The dx by dt gets replaced with the 1 over t plus 2. And now we need to think about our limits. I can see my lower limit of x is ln2, and my upper limit of x is ln4, but I need my limits in terms of t, not in terms of x. So, let's take our x equation here and use that with the limits. So, if I say that ln2 is equal to ln t plus 2, then clearly comparing, the 2 would have to be equal to t plus 2, so t is 0 at that point. Similarly, when x is ln4, if I say ln4, again using this equation here, ln4 equals ln t plus 2. Then t plus 2 has to be equal to 4. So t is going to be 2. So I have my lower limit of t, which is 0, and my upper limit of t, which is 2. Right, we need to integrate this product that we have here, this product of 1 over t plus 1 times 1 over t plus 2. Well, first I could just combine those two fractions together to be a single multiplication. But I don't want it to be a product there. I'd like to split that up into its partial fractions. So I want to split this up to be the integral of something over t plus 1 plus something over t plus 2. Right, let's do some partial fractions work down here at the bottom. We've got the right, so let's cross multiply here then. We've got the a times the t plus 2 plus the b times the t plus 1 now my denominators are the same. I can cancel those and just focus on my numerator. So what values do A and B need to have? If I let t equals -2 first of all, that's a good idea because this term here will just become 0 now. And so I will just be left with 1 is equal to b times -2 plus 1. So we can see that b must be -1. So I'm going to plug that -1 here. Now to work out the a term. This time I'm going to let t be -1. That way, this term will disappear. And I will just be left with 1 is equal to a times -1 plus 2. So a will just be 1, which I can plug here. Right, thanks to that partials fractions work, I can now go back to my integral. Because we know what a and b are now. The a was 1, the b was -1. Right, time to integrate. The 1 over t plus 1 will integrate to be ln t plus 1 minus the 1 over t plus 2 will integrate to be ln t plus 2. Now I'm going to just use the laws of logarithms to simplify that a little bit. So I'll have the t plus 1 divided by the t plus 2. Substituting my limits in then, so I'll substitute the 2 in first. We'll get ln of 2 plus 1 over 2 plus 2 minus, now substitute the 0 in, 0 plus 1 over 0 plus 2. Now, ln 1/2 is the same thing as minus ln 2. And then the minus will turn into a positive, so I'll get ln 3 over 4 plus ln 2, which is the same thing as 3 over 4 times 2, which is ln 3 over 2.